All right, so here we are on Chapter 3. Like I said before, this is the original Chapter 3 test. This is what I'm picking. The retake test that we did was very much like this, except some of the numbers were different. And that's about the only thing that was different about it. All right, let's take a look. It says identify, and then I give you some choices. Oops, let me change my writing thing right here. Let's put it in red, and let's change that. All right. So what we have to do is it's basically, I guess it's multiple choice. You could call this multiple choice, couldn't you? It says identify each pairs as what? Corresponding, right? That's one choice. Corresponding. All right. It could be alternate interior. It could be alternate exterior, or it could be consecutive interior. So you got to tell me which one is which. So let's take a look. 3 and 6. So I'm going to mark it. I'll tell you what, I'm going to circle it. It's just 3 and 6. See those two angles right there? So which one are they? Are they corresponding, alternate interior, alternate exterior, or consecutive interior? Well, are they interior or exterior, first of all? They're interior because they're between these two lines right here, okay? And they're on different sides of the transversal. So they're not corresponding, because corresponding would be like in the same exact spot. Like, see that 3 and that 7? They would be corresponding. But what are 3 and 6? You know they're not exterior, so we know it's not that one. Are they consecutive interior? What does consecutive interior mean? That means on the same side, right? So like 3 and 5 would be consecutive interior. 4 and 6 would be consecutive interior. So, are they corresponding? No, because it would be 3 and 7, and 4 and 8, and 1 and 5, 2 and 6. So what's my other option then? Alternate and exterior, because they're on alternate. They're on opposite sides of the transversal. One's way up here, one's way down here. They're completely opposites, so they're alternate interior angles. Make sense? All right, so that's what that one would be. You can write it down. I'm not going to write it down. What about 4 and 8? Let's circle those. 4 and 8. All right, go ahead. Yes. What about these? Look, 4 is on the bottom right of this group, and 8 is on the bottom right of this group. So which one of these 4 things, Nathan? They're corresponding angles, okay? They correspond to each other. They're in the same spot. Would you agree? See that group of 4 angles? This is in the bottom right. See this group of 4 angles? This one's in the bottom right. So they correspond to each other. They're in the same spot. So they would be corresponding angles. 3 and 5. Let's take a look. 3 and 5. Well, we mentioned this earlier. They're not corresponding. They're not alternate interior. Are they alternate exterior? No, because they're not on the exterior, the outside. But they are what? Consecutive interior. Means they're on the same side of the transversal, okay? And they're interior. They're inside these two lines right here. So those would be consecutive interior. Now, I didn't ask. I only had 3 things here, and there were 4 options. Like, somebody give me an example of 2 alternate exterior angles. 2 and 7, very good. So 2 and 7 would be examples of alternate exterior angles. I don't know if I gave that to you on the retake or not. I can't remember what I did. But anyway, that's that. I may not give you like 3 of these just because I got to fit. How many tests? That's 4 basically. That's 80 problems. I got to fit 80 problems into 40, right? So not every one is going to be on there, all right? Remember, it is 40 questions, all right? 40 questions. It's basically a double test, all right? Because midterms always have to be a little bit longer because it covers half a year. All right, let's do this. Now that we know those things, I tell you what, let's do this. Let's go back to this. They don't ask this, but like 3 and 6. 3 and 6, they're alternate interior angles. What's true about alternate interior angles? What's the relationship between them? They're equal to each other. They're equal to each other. Okay, I'm going to get rid of those things right here. Or you could look at it this way. Watch. Look at angles 1, 4, 5, and 8. Everybody see that? See the 1 and the 4, the 5, and the 8? What type of angles are they? They're obtuse angles, okay? So what's true if the lines are parallel? This is only true if the lines are parallel, okay? Are the lines parallel down here? Yeah, they are, okay? If the lines are parallel, what's true about all the obtuse angles? They're all the same. They're all equal to each other. And what's true about the other angles? 2, 3, 6, and 7. They're all what kind of angles? Look at 2. Look at angle 2. What kind of an angle is angle 2? It's not obtuse. It's not bigger than 90. It's what? It's acute. It's less than 90. So 2, 3, 6, and 7, they're all acute angles. So guess what's true about all those angles? What's the relationship between all those angles? They're all the same as well, okay? So all the acute angles are equal to each other, and all the obtuse angles are equal to each other. Is the obtuse angle equal to the acute angle? No, that'd be impossible. That defies the definition, right? Because obtuse is more than 90, acute is less than 90. You can't have an obtuse and an acute actually equal each other. So with that said, let's come down here and see if we can do this. It says angle 1 is 115 degrees. I'm going to write it right there. 115. 115 degrees. Question says find angle 8. So where's angle 8? So what you could do is this. This is how I would do this if I were you. It just makes things way, way easier. I'm not going to worry if they're alternate interior, corresponding, same side, or what's that other one? Consecutive interior. I don't care about that right now. I just want to look to see, are they obtuse angles? Are they acute angles? All right, let's take a look. Look at angle 1. It's 115 degrees. So what kind of angle is that? It's obtuse. Look at angle 8. What kind of angle is angle 8? It's obtuse. What do we say about all the obtuse angles? They're all equal to each other. So what's angle 8? It's 115. No math involved. You just look at them and say, oh, they're both obtuse, so they both have to be the same. Here's one thing I didn't ask you. We'll probably have to do that here in a minute. What's the relationship between one of the obtuse angles and one of the acute angles? They're not equal to each other. We already said that, but they do something, though. They're supplementary, right, which means they do what? They add up to 180, all right? We may have to use that in a minute. And in fact, we're going to do that right now on number 5. Let's get rid of all this. Just a clean slate here. Angle 4 is 130, so this is 130 degrees, that angle right there. The question is, what is angle 6? This angle right here. Are they the same? No, they're not, because that's obtuse and that's acute. So if they're not the same, then they're supplementary. So how do I find what this angle is if I know they're supplementary? That's it. Take 180 and take 130 away from it. What's 180 minus 30 or 130? It's 50 degrees. So angle 6 right here is 50 degrees. You see that? Because we had a thing that said consecutive interior angles are supplementary. But also, it's acute and it's obtuse. That means they're supplementary. You just take it away from 180. And that's 50 degrees. Easy as that. Make sense? Okay, let's take a look at this. Angle 5 is 110. So this is 110. What's angle 4? This one right here. Let's take a look at angle 5. Angle 5 is obtuse. Angle 4 is what? Obtuse. So guess what? Angle 4 is 110. All the obtuse angles are equal. All the acute angles are equal. That's not hard to remember, is it? Right. Okay, so we're good with that. One more. Angle 7 is 60 degrees. So this one right here is 60. Oops, let's make that look a little nicer. That's 60 degrees. We want to find angle 8. What's the relationship between angle 7 and angle 8? They form a what? Form a straight line. Or you could look at it and say angle 8 is obtuse, angle 7 is acute. What's true about an obtuse angle and an acute angle in this situation? They're supplementary. So you can do this in your head, can't you? Can you do that in your head? 180 minus what? 60. And what's 180 minus 60? 120. Does that make sense? It's not hard if you understand that all the acutes are equal, all the obtuses are equal, and the acute and the obtuse add up to 180. If you can remember those 3 things, you should be able to do these problems with no problem at all. Yes? Adds up to 180. No. Adds up to 180. That the acute and the obtuse, anytime in this situation where you have 2 parallel lines cut by transversal, all the acute angles and the obtuse angles, right? Any obtuse and any acute will add up to be 180 degrees. We good? All right, let's look at this one. This one's the same idea. It's just a little bit more difficult because they're not just regular numbers, are they? You do have a regular number here, but then they stick an x in there. So what do you think you're going to have to do? You're going to have to find x. And in fact, they actually just ask you to find x, and that's it. Trevor. Wait till whoever left. Who left? Makai. Wait till he comes back, then you can go. All right. Let's take a look. Look at these two angles. What's the relationship between this angle right here and this angle right here? They are equal to each other. Okay, why are they equal to each other? A couple reasons. They're alternate interior angles. Okay, you can remember that and remember that they're equal to each other. Or you could say what, Nathan? They're both acute. That's the way I would look at it if I were you, okay? Then you wouldn't get real confused. They're both acute, so they must be equal to each other. So guess what you're going to do? You're going to set them equal. So that 2x minus 6, that's this angle right here. That's got to be the same thing as this angle right here. So if it's the same, I'm going to set them equal. And now, this is something we've done quite a bit this year, isn't it? Even though this is called geometry, we've done a lot of algebra in this geometry class. That's why you take algebra before you take geometry, all right? Because you need to know how to do some of this. So what's our first step to get x by itself? Get rid of that minus 6. How do we get rid of the minus 6? We add a 6. All right? That cancels out or adds up to 0. Bring this down. That's a 2x. Bring down the equal sign. Add those up. 54 and 6 is 60. One more step and you're done. Divide by 2. Divide by 2. X is 30. And that's it. That's what they ask for. They just ask you to solve for x. Just for the fun of it, let's put it back in just to see if it actually does work. Because this thing right here should come out to what? To 54. Let's see if it does. So put 2 times 30, which is 60. 60 minus 6 is 54. Yep, it does work. What about number 9, though? Look at this 62 and this 5x plus 8. Are they equal to each other like number 8 was? What do you think? Yeah, they're corresponding angles, or you could look at this. 62 is acute. This 5x plus 8 is obtuse. What's true about an acute and an obtuse? They add up to 180. So guess what we're going to do? We're not going to set them equal to each other because they're definitely not equal. What do? We take the 5x plus 8. Remember, they add up to be 180. These two angles right here add up to be 180. So I go 5x plus 8 plus what? 62. And that should equal 180. That's the geometry. The rest is just all algebra. That's the geometry. You have to see the relationship between those angles. They add up to be 180. They're supplementary. Now let's do the math, the algebra. So 5x plus, what's that, 70? Equals 180. And then it's the same step as we did over here. So I just subtract 70 from both sides. And I get 5x equals what? 110. Divide by 5. What's that, 22? X is 22. And that's it. That's your answer. That's what x is. We good? Yeah. It's not so bad. About to erase it. Everybody got that down? Why did I do what? Still can't hear you. What? Plus 8. 8 plus 62. Because it's 5x plus 8, right? Yeah, I just added them together. Yeah. I added like terms. Remember in Algebra 1, you had to combine like terms? Does that sound familiar? So you add those together. That's how I got to 70. Any other questions before I clear this out? Because I need some room to do this other stuff. Everybody good? All right. Let me get rid of all this. All right. Now, here we go. I'll tell you this. On the midterm, like this has 4 different ones. I'm not going to give you all 4 of these. I might give you like 1 or 2 of these. Like right here. This one and this one are kind of the same. I'm just going to pick one of these. I'm not going to give you both of them. Everybody understand that? Okay. and like right here. I probably wouldn't give you 3 of these. I might give you 1, maybe 2 of those right there. All right? Just because I got to take 80 problems and whittle it down to 40. So it's the same with, well, except for this. The whole reason I said that is this one you're finding the distance, the midpoint, and the slope. So I can almost promise you that you will have one where you have to find the distance. Okay, it'll be this one. It'll be either this one or the one from the retake test. Okay, and then you're going to have to find the midpoint. You're going to have to find the slope. All right, so it's guaranteed. Guaranteed. You're going to have all 3 of those on there, 10, 11, and 12. So make sure you know how to do these. All right. So the first one says find the distance between. So we have a formula, don't we? We have a what formula? Distance formula. Very good. All right, and you got to know how to use the distance formula. You got to memorize it. I'm not going to give it to you. You have to know it. So it's a distance equals then a big old square root. Do you remember what we put inside that big old square root? A couple parentheses, and you right, this is the shell of it. So parentheses and a squared, another parentheses and a squared. Okay? What goes inside this parentheses, though? What do we do inside this parentheses? We take the x's, and then we do what to them? We subtract them from each other. Then what do we do over here? Do the y's, subtract the y's, all right? So what x's and y's? Well, this is an x, and this is a y right here. This is an x, and this is a y right here. So again, do the x's, and we subtract them. 6 minus 2. We could do that in our head, but I'm just going to write it down. Go ahead. It doesn't really matter what order you do it. Yeah, you do the x's here, though, right? You only subtract the x's from each other, and you only subtract the y's from each other. And it doesn't matter what order you subtract them in. It makes no difference. Okay? And now we subtract the y's. The 4 and the 1 are my y's, so I subtract them. I'm done with my geometry. That was, actually, this is kind of like algebra, but anyway, I'm done with that. Now I just simplify it. Keep that square root. I noticed that a lot of you guys, you put the square root at the beginning and then you forgot about it at the end. All right, keep it there. So let's do the math. Do the parentheses first and then we'll square it. 6 minus 2. What's 6 minus 2? That's 4. And then we square that. 4 minus 1 is 3 and we square that. It's real simple once you get to this point, okay? Once you get your put everything into your distance formula, the rest is really actually pretty easy. And I'm not just saying that because I'm the teacher. I mean, it really is. 6 minus 2. How hard is that? 4 minus 1. How hard is that? Would you agree? What about this? 4 squared. What's 4 squared? 4 times 4, which is 16. Plus 3 squared. What's 3 squared? 3 times 3, which is 9. Okay? That's easy too, isn't it? I'm not just saying it. It really is. Keep the square root. Let's add the stuff in here. What's 16 plus 9? It's 25. Am I going to leave this square root of 25? No, because it comes out to a nice whole number. What does the square root of 25 come out to be? It's just a 5. Did I need a calculator at all on this? No, not at all. It just comes out to a nice 5. That's the distance. That's the length between those 2 points. Here's 6, 4. Here's 2, 1. The distance between them is 5. That's how long that line is, that line segment. Now, you may, if I pick the other, I don't even know what the other problem was, but it may not come out to a nice whole number. Like if it comes out to like the square root of 17, just leave it the square root of 17 because it doesn't simplify to something that's a nice whole number. Everybody got me on that? All right. Again, I don't know what the retake one said, but all right. Let's get rid of all that just to give me some room to write the next thing. All right, so you'll definitely, 100%, I promise, the distance formula will be on there, okay? A problem with the distance formula will be on there. I'm not going to give you the distance formula. You have to know it, just like I wrote up here earlier. All right, here's another one that I'm absolutely going to give you, all right? Find the midpoint of these things right here. So, midpoint. Well, the midpoint is a point. It doesn't come out to just one number. It comes out as an ordered pair. So my answer is going to be an ordered pair. I can't tell you how many times I looked at the tests and I'm giving people are giving me answers like 5 and 7 and -4 and stuff like that. It can't be. It has to be an ordered pair. Okay? It's a point. It's a midpoint. Everybody got it? Okay. It's got the word mid in it, so that means we're taking half. So my formula, I always do this. I always start off with over 2. Now, we're going to do something to the x's, but we're going to do something a little different than we did with the distance. We're not going to subtract the x's. What are we going to do this time with midpoint? We're going to add the x's together. All right? So let's take a look. Again, this is our x. That's our y. This is another x. This is another y. I'm going to take the x's and add them together. Again, it doesn't matter. You're adding. It doesn't matter what order you add stuff together. So I'm just going to add them. -2 plus what? -6, right? Because those are my x's. And now I'm going to put the y's over here. I'm going to add the y's together. So what are my y's? 5 plus what? Not 3. It's -3. 5 plus -3. Okay? Make sure you use the signs that are in front of them. And now we just work it out. Okay? This is pretty easy. -2 plus -6. That's -8. You got to know how to do that. But if you have a calculator, you can always put it in a calculator. But my goodness, okay, you shouldn't have to put that into a calculator. You should be able to do that. 5 plus -3 is just 2. And again, those are being divided by 2. Don't leave it like this. Always simplify your fractions. -8 divided by 2, it's -4. Okay? Then 2 over 2 is 1. That's your answer right there. That's the only acceptable answer. It's the only thing I'm going to accept. All right? You got to have parentheses. You got to have the comma. And it's got to be a -4 first and then a 1 second. It's not hard to do, but you got to know the formula, though. That's the key. If you don't know the midpoint formula, you're not going to be able to do this. You got to know the midpoint formula. All right? Super important. Everybody good? You okay if I erase this? Everybody's got it written down? Okay. Let's get rid of that. All right. Let's do this. Find the slope. This is another thing I'm going to give you. And on some of these other equations, or these problems right here, you're going to have to be able to do the slope. Slope is super, super important when it comes to math. In anything, in geometry, in algebra, in calculus, in all kinds of stuff. Okay, slope is really, really important. And in a class like this, unfortunately, you don't really see why it's so important. But if you were to go on to higher levels of math, you're going to look back on Algebra 1 when you first learned slope and be like, man, I had no idea we're going to use slope that often. In physics, you're going to use slope. In all kinds of things, you're going to use slope. So it's super important. So what letter do we use to represent slope? Do you remember that? M. Okay. It's kind of weird that it's an M, but I think I don't know, it's Latin or something like that maybe. I don't even know. I don't think people, because I looked it up, people don't absolutely 100% know where the M came from. But I always think of it as M for mountain, right? Mountain has slopes, it goes up, it goes down. That's what I think of. All right, so let's find the slope. Slope's pretty easy. It's a fraction. Remember, it's rise over run. Remember that phrase? Okay. So how do I find the rise? I take the y's and I do what to the y's? I subtract the y's from each other. Okay. And then on the bottom, I subtract the what from each other? The x's from each other. All right. Again, that's an x, that's a y, that's an x, that's a y. Doesn't matter what order you subtract them in, as long as you subtract the x's and the y's in the same order. Okay. Everybody hear that? I've probably said that 100 times between this class and my other class. I've said it so many times. So it's rise over run. So we do the y's on the top. The y's go on top. A lot of people think the x's go on top because x is first, y is second. But the y's go on top because it's rise over run. The y is the up and down. That's the rise. So we take the y's and we subtract them. 3 minus 7. I'll just do the first one minus the second one. All right, so I don't get confused. 3 minus 7. Everybody see that? Because 3 is this y, 7 is this y, and then I subtract them from each other. Put them on top. Now we take the x's and we subtract them. Make sure you subtract them in the same order, though. So if I went 3 minus 7, I have to go what? 1 minus 3. Everybody got that? That's how easy it is to do slope. Now we got to do the math. but that's not too hard. What's 3 minus 7? Negative 4. And then 1 minus 3, it's negative 2. What's negative over negative? Positive. 4 over 2 is 2. That's your answer. That's the slope. It's that easy. Again, it's easy to do, but you got to know where to put the numbers, though, right? That's the hardest part about this. The hard part about doing all three of these problems is not doing the arithmetic. The arithmetic's easy. It's figuring out what numbers you're putting in and then doing the arithmetic. Do you agree with that? Some of you would. All right. Let's keep going down to here. Let's look at 13. We got 15 minutes. We got a lot of time to get these finished, okay? So find the X and Y intercepts. Remember that? X and Y intercepts? It's basically where the line would cross the x-axis and where it would cross the y-axis. All right? So number 13, to find the x-intercept, we set something equal to something. Do you remember that? To find the x-intercept, we set the y exactly equal to 0. Again, that's what you have to remember. You have to know that in order to find the x-intercept, because we're finding two things here. We're getting two answers. We're finding an x-intercept and we're finding a y-intercept. Everybody with me? All right. So let's do that. Let's take this equation, or this little equation right here, and let's set the y equal to 0, and then we'll solve for x. So I got 3x minus 4 times y, or what's the y going to be? What did we set y equal to? A 0. See what I just did? I just replaced that y with a 0. Why did we do that? Because that's how you find the x-intercept. I'm not going to go through the whole routine on why you do it, but you can watch the old video if you want to. And now what are we going to do here? We're going to take this. All I did was replace that y with a 0, and now what I'm going to do is just find what my x is. So let's do the math. 3x minus 4 times 0. What's 4 times 0? It's 0, so I don't even need that, do I? So 3x equals what? 12. Divide by 3. X is 4. But I don't just write x equals 4 and circle it. Okay, it's an ordered pair. It's an ordered pair. So how do I write an ordered pair? 4, 0. Why did I make the 0 second? Because I set y equal to 0. That's right. And I found what x was. Everybody see that? That's half my answer. It's only half of it. Why is it only half of it? Because now I got to find the what? The y-intercept. That's right. So everybody got that written down? Because I'm going to get rid of it. It's just because I don't have room. What am I doing here? Shift. Okay. All right. Let's now find the y-intercept. So if I find the y-intercept, guess what? I'm going to set not the y equal to 0 this time, but the x equal to 0. Very good. Okay. All right, so x equals 0. So here we go. Here's the formula. It's 3 times x, or in this case, it's 3 times 0 minus 4y equals 12. See what I did? It said set x equal to 0, so I just replaced, whenever I saw the x, I stuck a 0 in for that. So what happens here? 3 times 0 is 0. So I've got negative 4y equals 12. And now I just solve for y. That's easy. Divided by negative 4, divided by negative 4, y equals negative 3. So how do I write my final y-intercept now? I put an ordered pair. Again, Logan? That's right. It's not 3. It's negative 3. There's a negative. It's kind of it runs together a little bit. But that's a negative 3. Why did we make this first one 0? Because we set x equal to 0. So that we put a 0 in for the x place, and then we solve for y. We put the y in for the y spot right here, the negative 3 in for where the y is. So I got two answers. What was that first one? I forget what it was. 4, 0. and then 0, negative 3. All right, so both of those have to be part of your answer to get that correct. Kenzie? All right, if you think of it, let me know. Everybody good with that? All right. Delete. Yes.
So, because you already know that when you add a 0, that number is just going to add up to 0.
It'll just go to 0.
Can you just skip that?
You can if you want to. I showed every little step so everybody sees where I got that from. But yeah, if you want to just skip that and then just do the X part, that's fine. Just make sure you, like right here, when you made this a 0, make sure you include that negative 4 there, because a lot of people would forget to do that. All right, let's do this. Find the slope-intercept form of this equation of a line. What in the world is slope-intercept form? It's something that, especially after you take algebra, and especially algebra 2, you'll be reciting this in your sleep. What's the slope-intercept form? You got it. Y equals mx plus b. All right? That's one of those super big important things that you're going to need to know in high school math, okay, is slope-intercept form. It's kind of like Pythagorean theorem. What's Pythagorean theorem? You should know that. A squared plus b squared equals c squared. Right. It's one of those things that, like, what's slope? Rise over run. See, there's certain things that, man, just click. Y equals mx plus b is one of those. You just roll off your tongue. So let's see. Here's the equation right there. So what do we want to do this? We want this thing in that box to look like this, right? So the y is sitting out there on the left-hand side by itself, isn't it? So that's what I want to do on this one. So what's in the way of that? Here, let me write it down. 3x plus y equals 1. So I want this to look like this. So what am I going to do? Subtract what? No, I'm not going to subtract the 1. I want the y to stay right here. Okay, I want the y to stay there. What's on the same side with the y that I want to get rid of, Logan? The 3x. How do I get rid of that 3x? That's it. I subtract a 3x. And I subtract a 3x from this side. So that goes to 0. So now I have y. Now you could do this. Now watch very carefully. This gets people confused sometimes. A lot of people just like to say 1 minus 3x. But look and see what my little slope-intercept form looks like. The x part always goes first, doesn't it? And then the b represents just a number by itself. That always goes on the end. So I don't want to write 1 minus 3x. How do I want to write this? I want the 3x to go first, so the negative 3x is going to go here. And then what's after that? Plus 1. It's a positive 1, so you got to put the plus there. And that's your answer. That and this are the same exact thing, except this is in slope-intercept form now. Did that make sense? That's all you had to do is just solve for y. Same thing with number 15. Now it's time starting to run out a little bit. So let's do 15 a little bit faster. It's the same idea. So it's 11x, I'll rewrite it up here, minus 8y equals negative 48. It's the same idea, but I got one extra step I got to do. Excuse me. I got to get y by itself. So what do I get rid of first? The 11x. So I do it the same exact way. 8y, or negative 8y, equals. Now watch what I'm going to do. I'm going to take this, I'm going to slide it over to the other side. But I'm going to put it out in front of the minus 48. Everybody see that? So I'm taking that minus 48, sliding it over. And then this, I'm going to subtract 11x from both sides. So that's what I get. I kind of skipped a little bit, right? I didn't show the minus 11x. I just told you that's what we were going to do. One more step and you're basically done. Okay, what is that? I got to get y by itself. So what do I need to get rid of? The negative 8. Okay, it's not just an 8, it's a negative 8, so I have to get rid of the negative 8. So I divide by negative 8. Now, what do you divide by negative 8 over here? The whole thing, exactly, both of them. So I divide this by negative 8, and I divide this by negative 8. Okay, that's dividing the whole entire right side by negative 8. What happens here? Cancels. Y equals, we're ready to write down our answer. This is negative 11 over negative 8. What's negative divided by negative? Positive. So I just write 11 over 8. Don't write it as a decimal. Don't write it as a mixed number. Just keep it 11 over 8. It's already simplified, right? And then you just put an X. And then what's this? Negative over negative. It's positive. Now we can figure out what this is. What's 48 divided by 8? 6. That's your answer right there. That is now in slope-intercept form. Again, it's the same exact equation as this, except we just get the y by itself. You see that? All right. Now we got some graphing to do. Let's get rid of this. And let me go grab that graph. I got a graph up here somewhere. That's a good graph right there. Copy that. Slide back down here. And let's tell you what. Let's put it right there. Make it a little bit bigger so we can see it. I'll just put it right in the middle. All right, I'm going to go through this pretty quick. I'm going to do this one in red. This one says y equals 3. So what we're going to do, so like 16 and 17 are kind of like each other. All right, y equals 3. So which one is the y-axis, which one is the x? That's the x, and this is the y. Agreed? This says y equals 3. So on the y-axis, we're going to go to 3, positive 3, and put a point. 1, 2, 3, put a point. But we're not done. A lot of you guys just put a point there, and then that was it. Okay, it's a line. So what kind of a line is it? It's a horizontal line. So anytime it's just y equals something, it's a horizontal line. All right, you're going to have to remember that. A lot of you guys forgot. A lot of you guys missed this problem on the test, and this is like a gimme. This is like an easy problem that you should be able to do. Let's do another one. X equals negative 4. So this time, we're not going to go on the y-axis. Where are we going to go? On the x-axis, where? To negative 4. 1, 2, 3, 4. Put a dot right here or a point right there. Now, it's not going to be a horizontal line because it's x equals. So what kind of line is it going to be? It's going to be a vertical line. All right, it's going to go up like this, and then it's going to go down like that. All right, and then put the little arrows, and there it is. So those are those two, 16 and 17. Piece of cake. Would you agree? Super easy. This one's just about as easy. Okay, we're not finished, so don't pack up yet. Look at this one right here. Y equals 3x minus 1. What is the minus 1? It's the b. It's the y-intercept. So watch carefully. What I'm going to do is the minus 1 first. It's the y-intercept. It crosses the y-axis at negative 1. So I put a point at negative 1. But I'm not done. I got to put another point in there. Where do I find that point? I find it from the slope. So the slope is 3, or it's 3 over 1. Do you agree? That's the slope right there. So from the y-intercept, don't start from the origin, start from the y-intercept, and we're going to rise 3, we're going to run 1. So start from the y-intercept and rise 3, 1, 2, 3, run 1, put a point, and guess what we're going to do with those points? We're going to connect them. Put arrows on the ends, right there, and right there. And there's that one. Pretty easy, right? Tell you what, I'll do this one in yellow as well. This one's just as easy. A lot of people skip this and even use this as your free problem. But this one's just as easy as 18. I think, tell you the truth, it might be a little bit easier because on this 3, you had to understand that the run was a 1. But look at this one. Y equals 2/3 x plus 2. Watch how easy. I'm not just saying it, okay? I promise. It's super easy. First thing we do is do the y-intercept. What's the y-intercept? It's 2. 1, 2. Put a point at 2. Now look at your slope. Your slope is 2 over 3. That means we rise 2 and we run 3. It's as easy as that. There's no math involved. It's just putting a point and counting. That's all it is. So watch. I rise 2, 1, 2, and I run 3. 1, 2, 3. There's my 2 points. You obviously know what we do now. We do that, and we do that. And there is that one right there. Now this one right here, I'll tell you what, I won't put this on the midterm, okay? So I won't put that one on the midterm. I mean, it's not that hard, but just since we didn't get a chance to go over it, I won't put it on there. You like that one? Well, you don't have to take the midterm, so it doesn't make any difference.